So we're now going to look at several applications involving quadratic functions. So we'll begin with an example that says the marketing department at Texas Instruments has found that when certain calculators are sold at a price of P dollars per unit, the revenue R in dollars as a function of the price is R of P is equal to negative 150 P squared plus 21,000 P. Now, as we start this problem, what you need to realize is that the beginning of the problem is quite wordy, but the main thing that you need to focus on is the equation. Okay, so we know that this equation, R of P equals negative 150 P squared. This is a quadratic equation, just like we've been talking about in this section. Okay, now what you need to do is go through the problem, and we need to take our variables and we need to know what is being played by the R and what the P stands for. So that's the first thing that I'm going to work on. It's fairly straightforward because here it says that the revenue is R. All right, and it says that the price is P. Now, the other thing that you need to realize is you need to determine which one is like the X and which one is like the Y. The easiest way to do that is to think about your typical function notation, which looks like f of x is equal to, and then you have your quadratic function. Normally, we have an x on the left side of the equation in the parentheses, but this time we have a p on the left side of the equation in the parentheses. So what I'm going to do is make myself a note that the p and the x are the same thing, okay, that the x is being played by a p in this particular problem. And then sort of by the process of elimination, the other value is going to have to be the y. Okay, and that's just going to help me when I get to the point of answering the questions to know whether to write down the x or the y. Okay, with that done, think about whether this parabola is going to open up or down. And let's get a sketch drawn really quickly. Okay, so we know that if we're looking at the a value, and remember that the a is the number sitting in front of the squared term, so the a is negative 150. Remember that if the a is negative, then the parabola is going to open down. All right, so just kind of a really rough sketch. This parabola is going to be looking something like this. All right, and then the question is talking about a maximum revenue. So we have talked about this top point in the last section as being the vertex, and it is the vertex of the parabola. But you could also look at that vertex point and say that it is a maximum point. It is the top point on the graph. So when it starts asking us in these questions to maximize the revenue, it is asking us to find this maximum point on the parabola. So how do we do that? How do we find a vertex point? Remember that our formula for finding the vertex is x is equal to negative b over 2a. All right, so let's plug in. So we know that the a value in my function, we've already said, was negative 150. The b value is the number that sits in front of the variable that's like the x, or in this case the p. So the b value is going to be 21,000. And there is no C value, so C is 0. We don't really need the C anyway. Okay, so let's plug in. So where I have a B in my formula, I am going to put 21,000. And where I have an A, I'm going to put negative 150. So I have negative 21,000 divided by negative 300, which is going to give me 70. So I know right now that my vertex point has an x value of 70. Now, how do we find the y value? Remember that we take our function and we plug our 70 in. Now, keeping in mind that, remember that we've already made a note up here that p and x are the same thing. So if x is equal to 70, that means p is equal to 70, and we're going to plug it in. So I'm going to come here, and where there's a p, I'm going to substitute in a 70. And also back here where this other p is, I'm going to substitute in a 70. Okay, so I'm going to have negative 150. 70 squared is going to be 4,900 plus 21,000 times 70. And then at that point, I'm going to go to my calculator with it. And just type that in. All right, so that gives me 735,000. And that's going to be the y value in my vertex. Okay, so we want to look specifically at this vertex point as we answer the questions. So the first question says, what price? So remember that price is the p and also the x. So what is the x value in your vertex? The x value is 70. The second question says, if this price is charged, what is the maximum revenue? Remember that the revenue is the r, which is also the y. So the y value in my vertex is the other value, 735,000. All right, so now we've done that problem. Let's move on and look at another one. All right, we're going to move through this one a little bit quicker. All right, so now that you've seen an example, this one is going to work the same way. We have the daily cost to produce X TVs is given by, and we have our function. How many TVs should be produced to minimize the cost? What is the minimum cost? So if you look at your quadratic function, keeping in mind that the A value is going to be 1, since that is a positive number, we know that the parabola is going to open up. So our parabola is going to look something like this. The vertex will be the lowest point on the graph, which could also be thought of as a minimum, which makes sense because they're asking us to minimize the cost in both of these problems. All right, so our job is the same. We need to find the vertex. So I know that A is 1. I know that the B value is negative 80. And I know that the C value is 2000. So I'm going to find my vertex first. I'll do that by using my formula. X equals negative B over 2A. Right, where there's a B, I am going to erase that B, and I'm going to put a negative 80. Where there's an A, I'm going to erase that and put a 1. So a negative negative makes a positive 80 over 2. And so we end up with 40 for our X value. Okay, and then I'm going to plug into my function to find the Y. So everywhere there's an X, I'm going to be substituting in a 40. And then I'm going to work it out. So 40 squared is 1600 minus 80 times 40 plus 2000. And again, I'm going to go to my calculator with that and type it in because that's going to be a little bit easier than working it out by hand. And so I get 400. So now I know that my vertex point is 40, and then the Y value is 400 that goes with it. All right, let's answer the questions. So keeping in mind that the question asks first, how many TVs? We know that X is the number of TVs. So how many TVs should be produced? What is the X value in your vertex? The X value is 40. What is the minimum cost? That should be the other number, so that will be 400. Okay, one final problem. We have a projectile that's fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal with a velocity of 400 feet per second. The height h of the projectile above the water is given by, and they give me the formula, where x is the horizontal distance of the projectile from the base of the cliff. Again, that problem gets very wordy, but what you want to focus on is you have your function. Okay, so focus on that function, which we have right here. Keeping in mind that that's a quadratic function. All right, we know that x is the horizontal distance, so we're going to use that. We need to remember that. And h is the height. Okay, so will this parabola open up or down? If you look at the number in front of the squared term, it's negative. So a negative a value means that the parabola will open down. Okay, and it's asking us to find the maximum height. So keeping in mind that your vertex will also be a maximum for this particular problem. All right, so let's work on finding that maximum height. So I'm going to use my formula. X is equal to negative b over 2a. Now, let's write down the a, b, and c just to make it a little bit easier. And I'll tell you that I'm going to, for the a, I'm going to go to my calculator and get a decimal for that a value. So I'm going to put in the negative 32 and divide it by the 160,000. And I'm going to get as an A value 0.0002. The B value, the number sitting in front of the X, is 1, and the C is 500. Okay, so now I'm ready to plug in. In place of the B, I am going to plug in a 1. And in place of the A, I am going to plug in that decimal, 0.0002. All right, so let's go to our calculator. And that A value is negative, so let me be sure that I get that there. All right, so let's go to our calculator and see what we get when we do that. So if I take on the bottom of that fraction 2 times a negative 0.0002, that's going to give me a negative 0.0004. And if I divide those out, that is going to give me 2,500 for my X. Okay, and then let's go ahead and determine what the Y value is going to be for that vertex point. All right, so I am going to take my equation, and again, I'm going to use the decimal value for the fraction. So negative 32 over 160,000. We're going to have that, and then the X squared plus X plus 500. And what I'm going to do now is plug in the 2,500 for the X values. So that's going to give me this decimal times 2,500 squared plus 2,500 plus 500. And again, I'm going to go to my calculator, especially because the numbers are so large, and I'm going to type this in. And so that's going to give me 1,750 for the Y value. Okay, so now we have our vertex point. Let's look at our questions. All right, so the first question says, find the maximum height. So we know that height is being played by the H. All right, and remember that this is our Y over here. Y is equal to, so we're looking at the Y value in the vertex. So that's going to be 1,750, and our unit will be feet. Okay. All right, our second problem, the second part of this one, is a little bit different than what we've seen in the other two cases. So I'm going to make myself a little bit of room here. All right, so the second problem says, how far from the base of the cliff will the projectile strike the water? So we're not looking at anything at this point to do with the vertex, but instead we're looking at when the projectile strikes the water. So this projectile is shot up, it has a maximum up here, and then it comes back down and it hits the water right here. So at this point is what I'm trying to find, when it hits the water. So what do I know about either the height or the distance when it hits the water? Well, I know that when it hits the water, the height is going to be 0, okay? Because the problem says that the height h of the projectile above the water. So when it strikes the water, the height is going to equal 0. So let's take that and see if we can work out this problem. So what I'm going to do is take my function, and in place of the h, which is on the left-hand side, I'm going to put a 0. Now again, I'm going to take that negative 32 over 160,000, and I'm going to put it in as a decimal just because it's a little easier to work with. Okay, so now we need to solve this quadratic equation. So remember our options for solving a quadratic equation. We can factor. I'm not sure I want to factor with that decimal leading in the front. We can do quadratic formula, we can complete the square, we can extract the roots. It's not really in the format to extract the roots, so it's either going to need to be a complete the square or a quadratic formula. Most people would prefer the complete quadratic formula. So let's go ahead and go with that particular method. All right, so I'm going to write my quadratic formula down. And I'm going to plug in. All right, so everywhere there's a b, I'm going to be putting a 1. Everywhere there's an a, I'm going to be putting that decimal. And then for the C, I'm going to be putting in the 500. Okay, so let's see what we can do to work this thing out. All right, underneath my square root, all right, 1 squared is going to be 1. That part's easy. I have 2 negatives, so I know that my answer is going to be positive on the fraction for the decimal part. All right, so on my calculator, I'm going to do 4 times 0.002 or 0.0002 times 500. So that's going to be 0.4. And then on the bottom, 2 times negative 0.0002 gives me negative 0.0004. All right, so we have negative 1 plus or minus 1.4 under the square root, and then negative 0.0004. Okay, so we're going to need to use our calculator to come up with both of the solutions. So remember that one solution will be found with the positive in the middle, and one solution will be found with the negative in the middle. All right, so I am going to use my calculator. And I'm going to do a little rounding. So my first solution that I get when I get the positive, rounding to the nearest foot, I get an answer of negative 458. Okay, so that's what I get when I put in my calculator this. Now, the question that I'm answering is, how far from the base of the cliff will I be? And I can't be a negative distance from the cliff. So I know right now that that is an extra solution, but it is not going to be the solution that I'm going to use because it's negative. All right, so I'm going to do the other one. So negative 1 minus the square root of 1.4 divided by that decimal on the bottom. So let's see what we get in that case. And again, doing a little rounding, that gives me 5,458. So that is a reasonable solution because it is positive. And so we're going to let that be the answer to the second part of this problem. All right, so we know that from the base of the cliff, the projectile hit the water after 5,458 feet. feet.